Good morning, everyone. Welcome back to our Connect University sessions. Today, the focus will lie on the evolution of computing technologies through the HiPEAC Vision of 2023. I'm Alex. I will immediately be here just to warm things up and just go through some housekeeping items, and then we'll move forward with our speakers. As you might remember, we started back in 2015 with Connect University, which is the knowledge sharing flagship initiative of DigiConnect, which aims to update both the EU staff and you, the audience, about the latest digital trends, as well as important digital policies. The scope of our sessions in general is to put at the same table EU institutions, industry, academia, and international organizations, helping us find inspiration from one another, as well as identify current opportunities and threats to shaping digital policies. For those of you who are not yet connected via Slido, we invite you to do so using the code HiPEAC. I'm saying this because over there you can ask us questions and we'll make sure that they make their way towards the speakers in the Q&A section. Also, if you plan on sharing any insights from today on social media, we encourage everyone to use the hashtags Connect University and HiPEAC. In terms of recordings, for those of you who cannot stay until the end, those will appear both on Futurium and as well on the Digital EU YouTube channel. Furthermore, Connect University will host soon sessions as well on blockchain services, open internet search, and the disinformation code. More information will soon come on Futurium. As for our speakers of today, we have Professor Koen de Boscher from University of Kent and HiPEAC coordinator, and Dr. Marc Duranton from CEA France, HiPEAC Vision coordinator. So without further ado, Max, please, the floor is yours.
Yes, good morning, and thanks to all of you either joining this Connect University session or listening into it afterwards. So it will be recorded, so you can listen to it afterwards. I'm the head of unit in DG Connect on Internet of Things, and I'm responsible for the research area Cloud Edge IoT for European data, a 350 million euro initiative over 4 years. And I have a special relation with HiPEAC because HiPEAC, I have a background in parallel computing when I started my professional career with a PhD in mathematics and computer science on parallel computing. So this has always been at my heart, what has been done here. And I've already been PO of this project and know this project officer, and I know this project since more than 10 years. So HiPEAC is a strange name. As an acronym, it doesn't tell very much, but it has become, in a way, an institution because it's there since 2004 with a different kind of setup. It contains all the renowned professors in universities and RTOs in computing in Europe that are engaged. Yeah, so I would say all of them. And over the years, we have also had a lot of industrialists, being from the research labs of industry, but also from the more operational side of industry, joining, and it has become kind of an institution also for brokering of skills, and in particular skills from universities. So HiPEAC bridges between industry and academia, like the HiPEAC Vision that we discussed today, is the more academic future vision. So it's a bit more long-term. And in parallel, we also have for example, the strategic research and innovation agenda of the key digital technologies joint undertaking, which is done by industry. So it's a bit the two of them that bring us a broad vision. And as opposed to other areas, HiPEAC has to bridge in computing between hardware and software because that goes very closely together. And HiPEAC cuts, from my point of view, across all the computing disciplines in computing, from embedded computing in smart sensors that become smarter and smarter at the very edge of the IoT, to edge processing, to cloud processing, to high performance computing, and last but not least to new computing paradigms that then like quantum computing that is coming. So the community is well known and not respected not only in Europe, but in the world. And there are two things I would like to highlight here. That is, first, there is this yearly conference. There was some disruption during COVID times, but then you resumed it as a hybrid event in last year in Prague, so far as I recall, and now the next one will be in Toulouse in January. Now, for the Commission, for us in Connect, the most important document is the reference document, is the vision that you're developing every 2 years, and because that helps us also in defining, it's a major background document for us to define new work programs in Horizon Europe. Now, let me come a bit to the focus and political context of the day. Maybe in 2020, I took a sabbatical as a fellow and guest professor at the University of Washington in Seattle, the world capital of cloud technologies, and I worked on geopolitics of innovation. Yeah, just at the start of the decline of the geopolitical situation, as I would say it. I mean, it was visible already before, but then it really started to go down every year. So I very much appreciate this theme of the vision of 23, that we are in a race with other world regions. I think that's extremely important. And maybe a highlight that I would like to report here on is Europe is back as a major player in the top 500 list. The second one of the top 10 was inaugurated on the 24th of November in Italy, with the President of the Republic being there. And that's Leonardo, the newest Euro HPC pre-exascale system, and it was inaugurated, and it's on place number 4 of this list, with another system from Europe already being on that list. But the race is not only technological, but it's also, I would say, geopolitical. You see the divergence of US and Chinese technologies when you look at, for example, how Android and Harmony, which was a derivative of Android in the past, but they are not converging, they are diverging. And that is what is happening on US and Chinese technologies. We also see a current conflict with the United States on subsidies, and the WTO rules are put in question again and again. You have seen that in the press over the last couple of days. You also see this issue of export control being an issue that may come back at some time. Some of the older ones among us, like myself, may remember them under the word COCOM restrictions during the Cold War. And I somewhat see that it could affect, if these things happen, it could affect many sectors. It could, for example, mean if an autonomous car manufactured by a European manufacturer has a high-end chip like an NVIDIA high-end processor in the car, they may not be able to export it to China because there may be restrictions. So they may have to have alternatives, abstractions, so to be able to exchange. So in that sense, that all leads to the point that Europe has to become as autonomous as we can. Autonomous doesn't mean we do everything ourselves, but we have to build on different suppliers. We have to become autonomous. And you see that reflected in many acts of this commission that were always announced by the President, Mrs. von der Leyen, in her respective State of the Union speeches when she announced it, and then when we afterwards made a proposal. And I can give you the last 3 examples of this commission. First, on batteries, because we need to be more sovereign, more autonomous on batteries. Second, on semiconductor chips, the CHIPS Act, I come back to that. And last, this was just now in September, on crucial raw materials, which we are depending on. So I think this, you see over the last years, how this has become policy of the European Commission. Now, if you look as an example at the CHIPS Act, which is closest, then you see technological leadership to be addressed there. So that's more the traditional path that we already know, a bit reinforced with more money and also with more pilot lines probably. So a bit more going also to the market. But you also see the security of supply, and that means improved conditions for investments in Europe. And you see already some results of that by the investment of Intel in Brandenburg in Germany. So when I look at your 6 themes of the race, I think I can fully endorse them. Race for artificial intelligence, moving also computing to the edge. so to where the data is. I think that's an important aspect. The race for the new web, the continuum, it's HPC, cloud, edge, IoT, but I would go further, the spatial web and what you call, at least what one company in the world calls the Metaverse. And I also think this evolution of the assistant Alexas of this world, as we see, how will they evolve? So that's the new web. The race for new hardware, quantum computing. Europe is doing quite well on this, but there are also other technologies like accelerators that we need in the car in the future that we have to see. The race for cybersecurity, I think, is an important point. And in general, then also the race for sustainability. I mean, we should not forget, with all the crisis today, or Ukraine, that sustainability is extremely important for all of us. The climate change is moving faster, and it's even moving faster now with these crises again. So I'm very keen to hear from you to bring that down a bit more on the technology discussion, but with this global political picture in view. So thank you very much for all of you joining this, and thanks to Koen and Mark for being here and sharing your views, the views of your community with us that you have compiled in your vision. Thank you.
Okay, thank you very much, Max. So my name is Koen de Bostra. I'm the coordinator of HiPEAC, and I will briefly introduce HiPEAC. So HiPEAC is an acronym. It stands for High Performance Embedded Architecture and Compilation. And our mission is to advance computing systems research and development as a discipline in Europe, basically. And we want to do this by bridging the gap between industry and academia, and also between the hardware and software communities. So as Max already explained just a few moments ago, so we are based on the system level. So we look at processors, we look at accelerators, compilers, runtime systems, the systems used to program and to use the hardware. We focus less on the technology level, which is below it. We keep an eye on it, but we are not doing active research in core research in that area. And also the application level on top of it, we are aware of it, but this is not the core focus of the HiPEAC network. In total, well, we have 5 objectives defined in the network. The first is that we want to secure and strengthen the leading position for Europe in computing systems. That's a very general objective. We definitely want to prepare the next generation of world-class computing system scientists, because we have a shortage of workers in this area, and we want to train the next generation. Then we want to build a dynamic ecosystem and bridge the gap between research, industry, SMEs, and also the policymakers. That's one of the reasons why we are here today. And also we want to align the research efforts in computing systems. And that's also the reason why we are here today. This has to do with the HiPEAC vision. There is a map here. So how big is HiPEAC? We count around 800 senior members, and they bring in their colleagues and students. So that's another 1,500. So in total, we have 2,200 people in the network, and we are organizing events to entertain the network. So we have a conference, the summer school for training, and we also have a jobs website with many vacancies at this moment to help the community to attract talent. One of the major activities we have is to create a biannual vision document, and that's a community effort, so the whole community can contribute to the vision. And once the vision is ready, it's there for the whole community to use in project proposals, in courses, whatever people want to do. And here you see the sequence of visions. So you have the last one, existing one, is the one of 2021, which has been updated in 2022. And at this moment, we are finalizing the 2023 version, which will be publicly announced in January 2023 at the conference. But today we will give a preview on its content. And for that, I would like to invite the coordinator of the vision, Marc Duranton, to start presenting the new vision.
So thank you very much, Koen. So I'm Marc Duranton. As Koen said, I'm the coordinator of the vision. This presentation today is a preview of what will be in the vision, and it will be mainly an highlight of the differences between the 2021 vision. And as Max already said, the general theme of this vision is that we are in race. First, in race against time because of external constraints like the global warming, but also because evolution of technology is very fast. For example, artificial intelligence. So already when the chapter of on artificial intelligence will be published, it will be already updated because of the progress. So each week we have to update it because it's going very fast. And we are also, as Max said, in a race against the rest of the world on multiple aspects. Economical, reducing our dependencies, our ethics. European ethics is not the same everywhere. It's not the same that in US or in other countries. So what we identify and try to cluster this into 6 races. The first one is a race for the next web, linked to the continuum of computing. What will be after the web, what we have today, and what will be the next big thing into this domain. So I will explain a little bit what is our vision on this. Artificial intelligence is now everywhere, and I think it's here for a long time. And it will be both at the edge, where we must be strong as Europe, but also in the big model that we call meta model, where today Europe is not very present. And of course, there is a race on innovative and new hardware, including quantum computing, but also a race for cybersecurity, race for sovereignty, both on the technological, on the product, on the content, and of course, a very important race for sustainability. So let's start with a global introduction of what is the past of computing system and what we could forecast. So during the past, so men were the main source of data, but we see that more and more data will be generated by machine. So already today, 90% will be generated by machine. So machine will be communicated to machine. So it's also why the web, which was more human-centric, will certainly need to evolve to support this new kind of application and new requirements. We see also the evolution of the society that was impacted by computing technology. If you see this picture from the beginning of last century in a big city, and if we see the similar picture now, we see that the smartphone has a drastic impact on our society, good or bad. But just to see how fast is it, because remember that the iPhone was only introducing 15 years ago. So here, really, that shows that we are in an urgency, and digital technology is going very, very fast. Just also in terms of performance. So I take this example to compare the evolution of computing. So I take what was the fastest supercomputer in 2018. I take 2018 because it was a round number, 200 of petaflops. So it's 2 to 10 to the power 17 floating point operation per second. And if we go to the previous one, which was a sample number, it was the Cray 2 in 85 that has 2 gigaflops. So in 33 years, we have 100 million times improvement in performance. If we take another domain like car, the fastest car of 85 was running at 300 kilometers per hour. If we make the same scaling factor, we should have now the Star Trek Enterprise running at 27 times the speed of light, well, if it's possible. But just to give you that compared to all other technology, this was very, very fast in terms of performance increase. But not only in performance, also in terms of efficiency. So if you see the Cray 2, it was 200 kilowatts. So Submit was 10 megawatts. So we have an increase of energy of factor 15 for 100 millionths time more performance. So that means that the energy efficiency rise to 2 million in 33 years. And really, this energy efficiency is the key drive of computing technology. So of course, it's obvious for the smartphone, for longer battery life, for edge devices that could be scavenging, but also this is a limiting factor for high performance computing. So here we could have exaflop in 10 years ago, but in terms of cost of ownership, in terms of energy, this was not possible. So at that time, the efficiency was less than 1 gigaflop per watt. So now we have exaflop because we are able to increase in 10 years by a factor 16 the efficiency of supercomputer. So so this is a number that is so that we reach 1 exaflop. So I think that next year I will have to update my previous slide because then we will have 2 exaflop next year. So then I could update it with the number. So really, this was driven by the technology, but also by a lot of other factors like improvement of algorithm, improvement of architecture. But we always see that, okay, what will be after the silicon? Well, there are a lot of potential winners like 3D stacking, like a carbon nanotube, like optical computing or communication, like a spectronic. But clearly compared to silicon, they are far less mature. And also one point which is important is to take into account this evolution of efficiency. If we see from these drawings, the evolution of their forecast of energy from the ICT domain, so from the same company. If we see their forecast in 2015, that was tremendous. But if we see now, that was far less, because it's very difficult to predict and to take into account the performance improvement of computing system. So of course, it's improving, but also all the technology and all the system are also improving in terms of efficiency. And that is basically what is called the Kummer's law, that it said that roughly every 10 years, we have more than a factor 100 gain in energy efficiency of computing system. And we should continue and find new way to do that. But of course, this has also a societal effect that is called Javon Paradox, is that when you double efficiency of a system or decrease the cost by 2, you have more demand than this factor 2. So also this drive to have more devices that could have also a societal impact and the sustainability, that could be also a problem. So we need also to take this into account. And clearly the message that we have here is that to continue to get efficiency in our domain, we need to have a global, holistic approach. So we need to start from application. So we need to define the right and the efficient application, but also defining the best algorithm to do that. And we need also to take into account that we could get large improvement from algorithm, of course, from how we implement this algorithm into machine by a programming language, by all the software stack, by how we code data. So now we are mainly coding data with bits, but we could code with other things like in time with the neuromorphic architecture or with quantum computing. It's another way to code information. And also architecture need to be really optimized, and of course technology. But it's really the combination, the global optimization of all these factors together that is important. And we really need to have a global co-design between application, algorithm, software, data coding, architecture, and technology. So here, what we are promoting is really to break the silos, because between the people that are only making application and don't care how it will run on hardware, and vice versa, technology that didn't take into account how they could be used into architecture and all algorithms. So really, we need to break the silos and to have a holistic approach to have the best system. So now I will start with the first race, which is the race for the next wave. So what will be the future of the computing system interconnected? So there are a lot of evolution of the web. So we could call Web 1.0, that was the first one where a user only get information, but all the data and the formatting were done at the provider seat on their server. Web 2.0 was more interactive, where you could put your data, your information, your movies, your chat onto the web. So that is where we are today. And there are a lot of discussion between the web, what will be the Web 3.0. But I think most of the people agree that it could be more a web where we connect a knowledge. And just to see this history, as HiPEAC, we have released a comic book to celebrate the anniversary of the web, where you could see all the evolution of the web in a more easy way to understand. So the second way important is the continuum of computing. What we see now is that application is not only a single piece of code that runs on a single computer. It's really distributed from the IoT with the smart sensor that provide data that are aggregated into edge system and subsystem that are linked together through a smart network on the services to go to HPC and cloud and the process for big data and data analytics that are linked back to a cyber physical system. So HiPEAC and the ETP for HPC, so the group working more on the HPC domain, trigger one initiative that we call the Transcontinuum Initiative, is to also try to break the silos between communities. And we started this TCI, where we have basically, at that time, at the time of the signature, 6 organizations working together to try to break the silos. So since we think some of them have changed name, but at the origin it was the ETP for HPC, so mainly on the HPC domain, EXO on the cybersecurity, BDDA, Big Data Value Association, so on the cloud, 5GEI, AUMAT, more on algorithm, CLAIRE on artificial intelligence, HiPEAC, of course, on IIoT, on IoT devices. So this is really a message that Europe is really considering that we need to break silos and goes into this continuum of application. So here you could see a more detail on the charter of the TCI. Next point, next trend that we see is the evolution of program. So we didn't program a lot anymore. We are using apps. And here also, well, for example, when you want to book an hotel room, you could either download all the apps from all hotels company, or using an aggregator, or using now, even you have aggregators of aggregator. So you end up with tens, hundreds of apps that are basically doing the same thing. I want to have a room booked in the best condition for me. So what you want is not all these apps, but you want to have the service to book a room. And also, what's the point also, you don't want to program, I want to look into all the apps, what are the best price for the location. I want to do it easily, saying to the system or with an assistant, find me the best room for my next trip to Brussels. So also now, when you are telling this to the system, and some assistants are trying to do that, implicitly you are programming the system. So here, what the system is doing is not programming, it's orchestrating all these service providers together. And we see also we have more natural and contextual interfaces. So less and less people are using keyboard, but more and more smartphone or voice interaction. And we see the start of the low code where you didn't even write with a keyboard. You use graphical interface on other things to communicate, to interface with computing system. So, and we see also with the smart sensor that computing is more and more linked with the physical world with this, so understanding voice, understanding images, context, and things like that. But we have also a problem here is the old classical computing system made for keyboards and display have a lot of things that are not well done for the interaction with the physical world that we could call a cyber physical system. So time is abstracted or not present at all. And in very few computing language, you could say, I want this task done in less than X millisecond. And if you are programming a self-driving car, you need to know what is the response time. Otherwise, it could kill somebody if the latency is too long. So that's that also linked that the computing is not predicting. So it's basically done to have the best average performance, but not the predictability of the performance. Having predictability is more important for safety action to be sure that the system is reacting in due time. And even in sensor, if it's missed the information, it cannot tell the real world, okay, could you do it again? So because now the computing system should be driven by the physical world and not doing the opposite like they used to do. So also all the non-functional property, like what is the energy consumption if I do this a line of code instead of this one? What is the latency? What is even the price if I want to access to a service is not going into account. So we need to add all these non-functional property together. And also interaction with the physical world are second priorities. Most of the time we are using exception, which with the name says is done for exceptional event. But if the task is mainly to interact most of the time with the external world, we need to have new improvement even on the basic, the basis of computing systems. So tomorrow's system have to cope with all these requirements. It's why the Web 3.0 will be something different. So it's need to link with the physical world. And there are initiatives like the Spatial Web Foundation and a working group of IEEE that try to define things that could help to have this interaction with the physical world. So equivalent to HTTP, so they call it Hyperspatial Transaction Protocol or Hyperspatial Modeling Language, that's allowed to have some description of the physical world to work with the computing system. So really, if you want to summarize, we have all the physical world and all the domain at the bottom that are creating various physical quantities, various information on various systems. And most of them now, they are ecosystems which are in silos. And we see that the new market, new solutions come through interoperability. If you have the silos of electric car, it's nice. But if you could combine it with the smart home, then you could use your smart car when you have a power outage, for example, or to offload the peak hour of power consumption. So by combining two silos, you could have better information. So that means that they need to have interoperability and all this. So this is the physical world that need to interact through secure exchanges. So security is very important. And with this idea that everything should be seen as a service with the cyber world, which is basically, in your view, either local, so done locally on premises, or distributed, decentralized resources with a swarm, federated fog computing, but also cloud in some way. It's also part of it. And of course, this system should be autonomous, be able to modify itself, adapt to the new events. So clearly what it needs to do is to be able to construct all this new application from all these services on the request of the people that want a service or a new functionality. As I say, taking into account this non-functional requirement. So for example, I have two services doing the same thing, but perhaps one is free, one other you have to pay, but it could guarantee the response time, or it could be local instead of being done at 10,000 kilometers from this. So this is an element that need to be taken into account when I orchestrate, when I select these services to make my function. So for that, we need high-level abstraction. And clearly the message also in terms of efficiency is that service and resources should be used where they are the most efficient. And of course, we didn't want to break everything. Everything needs to be built on top of existing technology, like IP, like the REST interface, like, for example, the new innovation onto the spatial web and things like that. So as you see, the core of this, so you will have all these services, is how you link them together on the request of the user that wants something to be done. So this is important to have this, what we call trustable, distributed, smart, meta-level OS. And for us, OS is not an operating system, but it's become an orchestrating system, orchestrating all these services together. And it's important that this is the part that need to be trusted, because it's what is really having all the data of the user, knowing what the user, when I talk user, it could be the personal user, but it could be also a company. So this is important that all this should be trusted by the user. And of course, in terms of privacy and safety for company data, it could be better that this will be running on the edge or on premises. So this is our global idea for the global web, for the next web. We didn't find a right name now, so if anybody has a good idea, we will be happy to use this thing. But this is also linked with new, or not new, but hype that are started by a Meta company at the beginning of the year. It's about the Metaverse. And for us, we could see that all these services, so all this swarm of services, need to be complemented with a digital twin. So you could have a model of part of the car that need to be aggregated together to have a model of the traffic in a city or things like that. So you need also to have the simulation as a service. And why simulation and not the real world? Because with this digital twin, you could have access to variables that you didn't have access in reality, either because you don't have sensor into this part, or also because in simulation, you could play with variables that you cannot really play in the real world. For example, time. In the real world, you cannot stop time, accelerate time, or even go back. But with a simulation, you could do it. So you could simulate what if I do that, what was the reason of that, so going back in time. So it's why it's very important also that the interface that we have between these services and the physical world should be the same that we could use with the digital twin. So for us, this is what we call the industrial metaverse. So it's how we could improve the efficiency of process through this virtual cyber world that we could call industrial metaverse. So for us, it's this combination of IoT, so sensors, so that the models, the simulations, the digital twin could be updated in real time, the cloud or the federated cloud, artificial intelligence, of this link with the real world, so the cyber physical system that are making the metaverse. So of course, it's not the view of some US company, but some others have the similar view. So Microsoft that also have this view that the metaverse is a link between the intelligent cloud and the edge, and IoT is used to make a real-time update of this model. So then it could be used for a lot of prediction optimization and things like that. So yeah, we don't know what will be tomorrow. So will the next web will be the Web 3.0 based on the blockchain or NFT, more privately, more commercial one? Is it more linked to this metaverse that could be built with game engine, or it's? But we think it will be more this interaction with machine, human working together to have a more optimized process, or more efficient or more green process, because if you are more optimal, you can optimize all the process here. So really the challenge for us is this interoperability and composability. So really what we call the orchestration here. So the key is to have really this defragmentation of vertically oriented closed system, to have this heterogeneity, interoperability, and also to take into account this non-functional requirement and constraint. Scalability, because it needs to scale to billion of elements, like the web scale now to billion of users on websites. Dynamic, because this will self-evolve, so you could add new services, some services could die and things like that. And also privacy is also a key asset, so it should be built from the start. And also, of course, security. So it's why we think that the next web should be really decentralized based on the, these shared resources and really intertwining the cyber world and the physical world. So that's the main difference with the previous Web 2.0. And really, we have the pieces of the puzzle, but the key challenge now is to put all of them together. And we think that for this, we need high-level abstraction. And the good news is that EU and the US NSF try to work together into some pre-competitive action to try to think together on how we could go into this direction. And of course, as I say, we didn't want to reinvent the wheel, and it should be built on top of existing technology to build this this smart orchestrator, because this is very complex. So human user will be overwhelmed with the complexity of choosing in real time of this. So that is a good link for what we see as evolution. So today we are more cloud-based, where the clients are more sample or passive, to what we have today and what we promoted in the last roadmap, what we called at that time the cognitive cyber physical system, where more things are delocalized to the edge. And now we go to the next step, where the distribution is decentralized and embedded intelligence, so repository of knowledge that are orchestrated by this smart orchestrator that are linked to the web. So I will not go into detail of all the recommendations, because I think most of the message are here. But you could think of this idea of a continuum, non-functional specification, how we could make concrete demonstration of this trusted orchestrator, and that need also standardization, and also linked to this artificial intelligence at the edge, which is the link to the next step, which is the race for artificial intelligence. This could be faster, in fact, because you see that the top level artificial intelligence, so the state of the art, are bigger and bigger. And it's equivalent to the more slow but are fast growing race. So they basically grow by a factor 4 every month. Well, at least that was the trend. Recently, we see that it's not always the case, and the biggest models are not necessarily the best performance because they are more undertrained. So it's better now to feed more data to this model that's increasing them. But the problem of this is that if you feed them more data, then it takes more energy for learning. So you see here the exaflop, and we see here that all these models need more a tremendous computing power. So if you have an exaflop machine, it will even take days to train most of these models that, of course, have a very amazing properties. So I think that you all know the result of this large language model like GPT-3, generally based on a transformer that was, let's say, the next step after the deep convolutional network, where here you could have, with this artificial intelligence, you could get a specification in text, and they could create a lot of things, software, image, like this. So it's why I enter saying, okay, draw a cute otter in the style of Disney, Pixar with detail first. So it's what is creating. So I also asked to this system explain what will be the next breakthrough in computing. So you could see that the big hype since last week was a ChatGPT, and you see that okay, it gives okay answer. And of course, I ask it what is HiPEAC. So the previous generation knows HiPEAC, and see what are the key areas, and they are not totally crazy, but okay. So that means that all this model could be helper that could help us to think better and to start to have more idea. But of course, the key point is that we should not trust them as it. So as new technology, they have a positive or negative aspect. So it's always us men that are responsible of the usage of this technology. So even if they seems to have human-like interaction, we should not anthropomorphize all this artificial intelligence, and we should use them as what they are, tools. And again, here we need to have a global view to be aware what they are capable of, what they are not capable of. So it's clear now that they have what specialists called artificial intelligence hallucination, is what when this model are generating inconsistent, factually incorrect statement, because they don't know the reality, they didn't have thinking, but they could help in summarizing and things like that. But again, we should have a critical view on their results. So it's why we should consider them as an helper and not delegating everything to them. And also for the global view, we have a lot of people complaining about the energy of this model. So this is a publication from the MIT that shows that even a small transformer model consume or use more CO2 than 5 cars during their all complete life. Yeah, that's true, no problem. But of course, we need to have more efficient computing system to do that. So that is the work of the IP community to make more efficient system, but also in the use. So this is for the training. But if this after will be distributed into 1 million of systems, and each of them allow to save 1% of energy, of 1% of materials, then the global result will be positive. So again, think holistic. When we have this. So what we really see is that the next trend, the societal trend linked to AI, is really trust and frugality. So this is what people are more, what we need to develop. So to have more trust, because this system sometimes generates things that have no common sense. So we should be able to evaluate and to discriminate this. So this is a big challenge. Or we need to have people that make the selection. They need to be frugal in terms of energy, in terms of resources. And also here, the migration from cloud to edge, that's avoid to communicate data, is a key asset for this idea. And for optimization, and here we could see that is a chicken and egg. To be more efficient, for example, Google developed their own accelerator, and they have an evolution of system every 2 years. They make a new generation, but it's because they have the system that that some company linked to Google could make this new mega model. So it's chicken and egg. To make more efficient, we need to develop hardware, and then this allows to have new, better models that could have a new application in this. So also one point that's also raised is that for the same performance, the algorithmic improvement of artificial intelligence is also increasing, meaning that for the same performance, the computing power needed is decreasing by a factor 2 every 6 months. So it's we could create a new law here, but I will take a few examples. So GPT-3, what was discovered or was made public in May 2020. MetaOpt, which has globally the same performance, was made public 2 years after, and it consumed only 1/7 of the CO2 footprint of GPT-3. The previous voice model, so voice recognition translation, use a gigabyte of data and were only able to run on the cloud. But now the translation could run locally on your smartphone. And this is mainly for the inference. So we still need learning that need a lot of computing power, but for inference, so like translation, it's inference, it could run locally. So I think this is very important point. It's not because now these mega models are only running on the cloud that we should not consider and be prepared that in the future they will run on the edge. And here, Europe should be prepared to even be at the forefront to first master this mega model, which is not the case today, but also be able to run them at the cloud with optimization of the hardware and of the software. And for example, 3D face reconstruction that previously need a farm of GPU could run now locally on a PC without even using GPU. So that means that now you could have your avatar synchronized with your voice for a teleconferencing. So this is good, except that this could also have bad effect because it's also democratizing the possibilities of deepfake in real time. So again, here, pro and cons, but it's up to us to do that. So clearly the point also, besides this big model and more at the edge, is that artificial intelligence is adding perception to computer. So the link with the physical world. So this is really the link between AI and what we explained previously on the next web. So AI is a key element to make the link with between the real world and this cyber world. And you see that now computing systems are not anymore a PC. So a self-driving car will be a computer on wheel. These smart loudspeakers are also computers. So again, here for AI, we need to have an holistic approach. So using applications that are using efficiently the AI techniques, also having the right algorithm, and we see here that they have an optimization of the algorithm from time to time, having the right programming or way to have interoperability or develop AI system easily, have the right software stack to code, to have an efficient code generation for the edge system, quantization, so using the right set of data and things like that. So it's why Europe, and of course, the right architecture and the right technology, that's clear. So it's why also we need in Europe to be at the forefront of putting this big model into hardware with all the tool chain that allow to quantize, to reduce the size of the neural network and to make optimization so that it could fit well into the system. And also to develop hardware, but here we are not alone. So you see that Amazon now could make some of their tasks in their system because they have developed accelerators. Chinese companies are making very low-cost system that could make voice recognition. But even in Europe, we are not behind because this is, well, I checked last July on the best in terms of the TinyML benchmark. So it's an internal, it's an open benchmark to recognize a keyword or to recognize image. So that was a European system that has a very low power consumption in microjoule. So again, this is important. We could go to new technology, also neuromorphic, which is also linked to new coding of information in time and not in space, using parsimony and using physics to make computation, like the Ohm's law to make the product and the Kirchhoff law to make operation. And again, here, Europe is not lacking behind, because if we compare the results of European projects like NeuRAM3, but there are other, we are even in par and even better from the other system. So the point here is that we see more and more complexity. And as I said before, we should use computer to help us. So using artificial technology to help to create us new hardware and new software. So this was done in the past, so where artificial intelligence could help to make hardware which is order of magnitude more efficient. And it's the same with software. I like to show up this slide, which was from 5 years ago, where we say that computer need to make the job. So human should give the specification, and we should know on the computer need to tell how this will be done. This is done now with OpenAI Codex that could generate code, or Alpha Code that is in the average to generate code. Again, here it's not perfect, but this is also where we could use artificial intelligence as a helper. So again, here you will see all the recommendation in that we will have in the HiPEAC Vision. To finish my part, I will be very fast on innovative and new hardware. So of course, there is technology. So there is technology going from the classical transistor to now the nanosheet transistor. But this takes time. So this is just to show you that the first test of the nanosheet were done more than 15 years ago. Well, this is what my colleague at CEA in Leti did in 2025 and 2026. So it's not even yet in production. But they say that now the time of technology is slow. So, but we need to go on other domain, like putting together the new technology into assembling and going beyond chip level technology, which is called now a chiplet and interposer. So the idea is using 3D stacking to compose your system by assembling smaller part of the component. So we see also that the big company like Intel is going into this path, and you see that their last development is really using this 3D stacking system that's ended up with a very large system but very efficient. And again, this will go into edge system in the coming years. So, and the next step here is also using photonics. So here with the 3D stacking, we could make easily interface so that we could use photons, which are more energy efficient than electrons because they didn't dissipate at the board level, but perhaps also next step would be at the chiplet level. But we could also think that we could use light to compute. And for computing, the key element is not computing, not making the computing itself. So you see here, making on a double precision operation took 20 picojoule, but that's clearly what takes more order of magnitude is bringing data to this compute engine. So the next track is to avoid to move data. So what is called computing near or in memory. So here using new technology. So this is also will be developed in the 2023 HiPEAC roadmap as a new track that Europe and we should follow here. And of course, there is quantum computers. And well, but as you see, a computer is a lot of classical computing. Only the pink part here is the physical quantum part. And also in terms of software, we need to develop a lot of software and tools. So here, the classical HiPEAC community need to work together with the HiPEAC community, with the quantum system, both on the hardware side and the software side. So also here, we have a few recommendations. So just to summarize in terms of new hardware, again, here we see this heterogeneity increasing, and we see that the classical computers processor will be more the orchestrator of accelerator. That could be neuromorphic, that could be a GPU, that could be quantum. So here also, how to make this integration, how to make this orchestration between systems that even didn't represent information on the same thing is a key problem. And this is, let's say, the localized part of what we showed in the next web, which is more decentralized. So as evolution of processing architecture in the past, with before Dennard scaling ends, we wait for the next technology node, we increase the clock frequency. After, when Dennard scaling stopped, but still more slow, we use parallelism. So now we are in the array where we have more heterogeneity. That's add complexity to the software development and where AI could also help. But we see that in the future, it will be more into disruptive architecture where processing and the storage data will be more intertwined, and also new computing like quantum and photonics. Before going the floor to Koen for the societal aspects, just one point about cybersecurity. This is becoming more and more important. We see that cyber attacks, cybercrime, cyber war is in every news. So this is a very important aspect in our roadmap. And of course, we have also here recommendation, but in view of time, I encourage you to read the HiPEAC roadmap when it will be published. So now I give the floor to Koen on the race for sovereignty.
Thank you, Mark. So there are two more races to go, one for sovereignty, and maybe I will bring a message which is not so convenient for this community, but still we believe we have to bring them. So the different, we have the European Act, which wants to bring digital sovereignty at the hardware level to Europe. So there's billions of euros being allocated to that in the coming years. So that's good. But as a community, we think that it's also very important to think about the software, and we call them the digital essentials. So what's important is not only the hardware, but also the software, which runs society, which runs the economy. And we believe that we should find some way to make sure that services could be guaranteed, whatever happens outside Europe, I would say. So imagine that one of the major companies that are now providing us with services like Google and Microsoft, that someday they go bankrupt or they are being bought by a very rich person, or maybe the local government says that they should pull the plug for the services to Europe, we have a problem. So we believe that we should strive for services that can be purchased, not licensed, so that nobody can pull the plug after you've purchased them. And we also believe that we need a strong protection of individual sovereignty. And so if we want to share images, for instance, to parents of the child, there should be no foreign government controlling what we are exchanging, etc. And open source is a way to guarantee that. So open source is important, not only for collaboration and for stimulating innovation, and the collaboration mostly between companies and also between companies and universities, but also to create soft power. So if we create good open source projects, and also the rest of the world is starting to use them, we create soft power, and that's a way to become interdependent with other regions, global regions of the world. Now, if we want to bring all the software and the hardware back to Europe, and maybe also other manufacturing, we have a small problem. So this is the labor market in Europe. And what you can see is up to 2008, the blue bars are the people joining the labor market at the age of 21 years. The orange ones are the people leaving the job market at the age of 65. Here you see a gap. In this area, these are the people, well, the valley or the Second World War, the effect of the Second World War. People who fought in the Second World War retired in that time frame. But since 2008 and 2018, something dramatic happened in Europe. So the baby boomers are retiring, and this is going on, which means that from now on, we are losing 1 million people in the labor market per year structurally. And you see already the effects, like here. This week I read that there is a huge European driver shortage because many drivers are going to, 30% of the drivers are going to retire between now and 2026. and they need 2 million drivers just to keep the economy running. And it's not only drivers, it's also nurses, doctors, teachers, IT people. It's all over the place. For instance, this is Latvia. For every 100 people retiring in Latvia, only 67 can replace them. So you go from 100 doctors retiring to 67 replacing them. So if you want to do digital transformation and the European green transition, how can you do this in this situation? That's going to be very difficult. This is the map of the brain drain. Red means more brain drain, green means brain gain. And you see that there is a movement from Southern Europe, Eastern Europe to Western Europe, and especially to the northwestern part. That's also important because if we want to have the Digital Chips Act in place, we will have to find places where we have enough people to do that. Europe is the school of the world, and we are excellent in research. So this is the world share of scientific publications. Blue is Europe. It was 25% in 2000. It's still 20% today. If you compare this to the US, it's much better, actually, the trend. And you see that US is losing actually to China. Publications is one thing, citations is another thing. If you look at the 10% most cited publications, Europe is doing excellent. So we're doing excellent research, but unfortunately, we cannot bring it to the market. So we have a cartoon here where you have a famous professor and doing excellent research, but the problem is that it's not always resulting in products, or maybe the products are created by companies in the US. And one of the reasons is this image. So this is the venture capitalist investments. Seed stage, early stage, later stage. The difference could not be bigger between Europe and the US. So this is a structural problem that we have here in Europe. And if we want to create companies that become global players, I think we should absolutely try to do something about the later stage investments, which are almost 100 billion euro less per year, that is, than in the US. Fortunately, of the 21 billion invested, 1/3 goes to ICT, which is excellent. Another third is in the bars over there, and then another third is spread all over the place. So that's not too bad, but here we need more efforts. So the recommendations are that we have to work for digital sovereignty, both in hardware and in software. Independence is impossible, but we could create interdependence, which is good. That means that we have some bargaining power. You can bargain with other global regions. We are, for instance, very strong in technology that is used in fabs. Open source is important, and we also have to invest in an more entrepreneurial Europe. And of course, the university should work on lifelong learning, because if we want to have a workforce to work in these high-tech companies, we will have to retrain people, upskill them, reskill them. We cannot wait until they leave the universities. So, and then the last one is sustainability, and that's another sobering message, I would say. So we asked some experts in sustainability what we could do here in Europe, and this is what they told us. In the 90s, chips were made of 11 elements. In the 80s, sorry, in the 90s, we added 4, that's 15. Now the current chips need 60 elements. They're coming from all over the world. So before they end up in your chip, the components of your chip have traveled around the world multiple times just to bring them together. Another problem here is very little of them is recycled. So the orange bars are what we recycle, the blue bars is what we import in Europe. So we absolutely have to change this, because these are the reserves that are easy to mine at this moment. And you can see that of some of these components, these are all components that we use in computers. Some of them, the reserves are good for another 20 years, 30 years, 40 years, but not forever. So we will have to recycle, we will have to do urban mining. And at this moment, and Europe has a lot of e-waste, so there is a lot of opportunity here in Europe. And the European Commission has already taken initiatives in order to improve that, but that's absolutely important. This is about the materials. There's also the operational costs, which is the power consumption. And here you see the difference between a TV, a laptop, and a smartphone if you want to watch a 1-hour streamed movie. And you see here that actually the device itself is consuming a lot of energy. That's the TV with the big screen. And the smartphone is hardly consuming any power, so it's 10 watts to watch a movie. Here you see that the devices are taking up a lot of energy. And what's even worse, for the low-powered devices on the left graph here, you see the orange part is the emissions for energy emissions for production. The energy that a device is using is dwarfed by the energy needed to produce the device for mining, but also for production, and also the gases that escape during production, etc. So that's on the left-hand side, that's for mobile devices. On the right-hand side, it's for devices in data centers, for instance, that consume more power. But there you see at this point in this graph, 80% here is still energy consumption. But over time, as we move to new technology nodes, the hardware will overtake. And that's, of course, a sobering message for our community, because our industry is making money from selling hardware devices, but the hardware devices are actually not so good from sustainability point of view. And they have the R model. Here you see the R model, and the best things you can do are the things on top, the smarter product use and manufacturing. And you see the first one is try to avoid making a product. Of course, that's not the message that we want to hear. The second one is make the product use more intensively, which means if you have a product, try to use it 24 hours, 7 days a week. And then the third one is increase the efficiency in product manufacturing, which might mean, in our case, use a lower technology node, for instance, because it needs less resources. So, but these are messages which go a little bit against the current trend in industry, where we want to sell more devices faster and replace them faster. So that's a sobering message. I have two examples. I'm going to stop. This on the right is a mechanical light switch, easy to recycle, just piece of metal, piece of plastic, very cheap. It lasts for 70, 80 years. On the left one, you have a digital one. It's using power all time because it's always on. It's a PCB, there are the chips inside. It's hard to recycle, and it lasts for not 30 years or something like that. So from sustainability point of view, the old one is much better than the left one. And this is one that is also interesting in this context. So this is the edge computing. If you think about it, if we add an edge level, we add more what we call embodied energy, so the energy needed to produce the hardware components. We can do that, but it only makes sense from sustainability point of view if we can take away hardware from the cloud level or from the far edge level. If we keep them the same, we are losing instead of gaining. Another thing here is that the edge level will process the privacy sensitive data, the video, etc. So if you are an attacker, you have a bigger attack surface and you want to focus on the edge level. So I think cybersecurity is very important at edge level, because if there's anything you want to attack as an attacker, it's probably that level, because there you find all the information that you want to use. So this is just, it's an inconvenient message for our community. It doesn't mean that we shouldn't do this, but we should be very careful and do it in places where it makes sense, and be careful also with the sustainability effect. So there are some recommendations here, but I already explained them. Maybe also the business models. I think it's also important to create business models that take the complete life cycle into account to make sure that sustainable solutions become competitive with the non-sustainable ones. That's also important. And also maybe we should find ways to make sure that we need less hardware and more virtualized services in order to reduce that footprint. So in 2019, this was the cover of the vision, and we were at some point where we had to make a choice between a number of options, and then we said the best way to predict the future is to invent it. This year, I think we are more in this situation that we know what we have to do. There's not too many choices at this moment. But we have to speed up. We should not wait and contemplate like we did here, but we should start running and go to the solutions as fast as we can. So that's basically the message we wanted to bring in the vision. Thank you.
Thank you, Koen. So I would now open the floor for questions. Just repeat that this session is recorded and it will be on our Europa and HiPEAC website. But through Slido, we have received several questions, and I will start with the first one and quite provocative one. Could you say who is leading each race and why?
Okay, so for the mega model, I think everybody knows that it's the big gamma. So mainly Google, with mainly its subsidiary DeepMind, which originally was a UK, well, still a UK company. So in the European part of the world, Facebook. And the reason why is that because these companies have the computing power, and you see that this is key, they have the data, so they collect data, and they have the need because they started to be able to analyze all the images for nudity, pornography, and things like that. So it's one of the drive why they need to have automatic analysis of images. And also a big model, yeah, a voice recognition. So the Amazon Alexa, the Google Assistant Siri are based on this technology. So clearly now, all this company, well, I could talk also about the Chinese Bytics also that have also all the data on all the technology, but they are perhaps less visible in Europe than Google Assistant, Alexa, and things like that. So clearly, these companies are leading because they have the data, the computing power, and the need behind this. That didn't mean that we cannot do it in Europe. In Europe, we have a computing power, but we have problem to block one supercomputer during 1 week to train a neural network. We always have competition between which group want to have access to the machine and things like that. Data, we don't have a lot of data, but we could, because also we have a strength here is our diversity in terms of language. And we have also a lot of data that are collected by the institution, which is perhaps not the case. So we could have a different way here. So our message here is that it's important. We need to organize. We need perhaps, so we did it in Europe in terms of physics with the CERN. So why we create some kind of similar organization where we work together to have enough weight in terms of processing power, in terms of aggregation of brains together, in terms of data, so that we could have this mega model for Europe. And we could see that they have also a societal impact. They could also help people that are not very confident into going to the digital world, could help them. So having a voice interface that are correct is far better for few older people than having accessing to a keyboard and things like that. So it could also have a societal drive where to help people to be more included into this digital society. Europe could invest into this organization so that commonly we develop with this meta model. So this is more a policy, but this is one of our idea to go in this domain.
Thank you, Mark. And there is another question. How can energy be included in scope? Can you give an example? Unless it was already given during the presentation.
Well, yes, there are models, but these models are not yet very well known in our community. So our community is very unaware of sustainability effects of computing. But if you look at the literature, so there are three sources of energy in the production. So you have the mining, the energy that you need to mine, and then you have the energy that you need in order to do the manufacturing in clean rooms, and that turns out to be quite a lot. And then you have also all the gases and the other stuff that you need in order to, because they're also greenhouse gases and sometimes they escape. So that's for the manufacturing, and that turns out to be huge, especially for low power devices. And then of course you have the energy which is being used over the lifetime of a system. At this moment, our community is working on models that can be understood by computer scientists and computer architects to try to assess the impact of the devices they are designing.
So I could also give a practical example. So Professor, Benju, which was one of the winner of the Turing Award, so the equivalent of the Nobel Prize for computing, is very well aware of the cost of artificial intelligence and is collaborating so that people could add one line in their code. And this code, and this will allow to have information about the energy, the CO2 footprint of the code itself. So we can with this instrumenting our code so that we could have a better understanding of the CO2 or energy consumption of the code. So there are several initiatives that started, but as could say, it's just emerging now.
All right. There is also a comment on this. Holistic is fine, but there is no time to solve all that before the energy consumption will go down. We need a drastic alternative and not predictable roadmap.
Well, I think that's one of the drive of this idea that we have a race. And as I said at the beginning, I agree with the comment. We have a race against time, and we need to be fast. And I think here the key element is that we have the ingredient in all the domain, but they are still in silos. So now we need to organize to make concrete result. That's it.
And then there is a related question. Which of these silos would be easier to break to make efficiency happen?
Difficult question here. I think that when you control most of the part, it's more easy. So, for example, HPC is a domain where they are very well aware of this energy consumption. So you know that some of the top supercomputers are use only half or 1/3 of their computing power because of the energy. So the community is already aware, and it's far more easy to go into this. And what technology they use could be rippled down in all domains. But the first element is to make people aware of that, and they think about this.
Okay. Then another question, which advantage do you see in rising the most in Web 3.0?
Well, I think that the point is to have more efficient processes, so also linked to the sustainability. And it's not only a web that's linked people, but it will be web that link people and machine working together. So to have a better result, more optimized processes on things like that. So that is clearly this conjunction of machines really helping human to have a better optimization of the process, using less energy, be more efficient, and things like that. So as I saw previously, so now we have the Web 2.0, which is human-centric. We have the IoT, which is interconnection of machine, and we need to, again, break the silos and put them together to have the best of both worlds, let's say.
Thank you. Another question is, how likely it is that the edge centralized and potentially more transparent computing would prevail over the centralized and less transparent? And probably the question would be in how long time perspective we can expect that something like that can prevail.
Well, as I say, in HiPEAC, we propose ideas. We are not implementing them. And so what will be the drive? It could be, as usual, if we follow the same thing, economical reason, regulations, like regulations about privacy, about data, on things like that, or also linked to the Green Deal or to other sustainability function. But don't underestimate the time, how fast this thing is going. Remember, it's what I saw. The iPhone was only demonstrated 15 years ago, and it's really changed totally our life or even our civilization. Just to tell you, in terms of technology, the silicon nanochips were demonstrated at the same time, and they are not yet in the market. So, so this is important to consider the different time frame. But yes, we are in urgency. We need to think about this. We need to have the critical mass so that things will change. So critical mass could be by motivation of researchers, of course, of users, because they will drive the market. And the Commission could also drive to go into this direction.
Thank you. So there was also, when you mentioned the regulatory aspects, there was also a related question. Are there any regulatory provisions to prevent that all these technologies are not used in nefarious, probably malicious also, means purposes in terms of transparency and access?
Well, we are technical guys, so we cannot really answer on this, except that at least in the domain of AI, there is a lot of action at the EU level to try to put, I don't say recommendation, at least for the beginning, and that could end with regulation. And we see that Europe here could be at the far front. It's what was happened with the GDPR, which now is implemented in few other countries. So as Europe, we could take regulation, and as it's also what I say. Ethics in Europe is different from ethics in US, ethics in China, or in other countries. So we should be proud of what we have, and we should promote it and enforce it through regulation also.
Can I just comment? I think Europe is well advanced in this, in regulating so that these things of misuse do not happen. You will never be able to totally avoid them. So they will happen. If you foresee it and make sure it doesn't happen, we are back in the Stone Age. Yeah, then they will not happen. But that will not work. So we can only be the leading world region who tries to keep it limited without limiting too much our innovation potential, because that's the drawback on this. Yeah. So, but I think Europe is with its regulation on AI, for example, is and also the data regulations that we have published over the last 2 years as proposals, or that are even through, they go into that direction. So we try what we can, but there's never a recipe for not. You always have to find a good balance.
Yeah, so probably Europe is leader in the regulatory aspects to be taken into account. But on the technology side, there is still one more question. Are you optimistic about the steps taken by EU to fill the technological gap with the US and China?
Well, I'm quite confident, because at least this was taken into account at the highest a political level. So at least there is a willingness to go into this direction. Again, here, so the willingness is here. So now we need to all work together so that it's happened.
Well, Europe is also very good at coming up with ideas. I think all the work at DeepMind is being done in Europe, but for the rest of the world, maybe it's a kind of Google technology. So I think we should try to get more of our inventions in Europe and to monetize them in Europe. And there you have the venture capital that is lacking a little bit, and the environment, the ecosystem in order to support that. But of course, Europe has also some disadvantages. If you have a product, you can bring it to the market in the US, 300 million people, all the same language, the same system. In Europe, you have to try to start again 27 times, the different languages, different regulations, etc. So, but on the other hand, it also helps us to adapt our services to the rest of the world, because the rest of the world needs adaptations too. And for us, it's day one that we have to take that into account. So I think we should try to build. Also, we should not consider it a disadvantage, but maybe an advantage in order to grow faster in other parts of the world.
Thank you. And I would read out the last question, quite holistic one, I would say. Isn't my brain a mega model or several ones? Is it more? It's more efficient than anything you described. we are missing something.
Okay, so you need to read the chapter, well, the forthcoming chapter, because we have an introduction of another model about do we need a big monolithic or distributed? And for example, some animals have distributed brain working together with different properties. So each neuron are going faster, but the communication are slower. And yes, indeed, for the time being, for certain function, indeed, the brain, the biological brain are far better. Well, I don't know if we need to have the same efficiency or the same inefficiency, because, well, we are good to take decisions, to interact with the physical world, but asking you to tell me what is 100th prime number, not good. A computer could do it far more efficiently than us. So again, this is depending on the task.
All right. Thank you. So with this, I think we have dealt with all the questions from the Slido actually. So I would like to close. Somebody said here, amazing presentation, a lot of things to digest. I feel about the same. So with this, I would like to thank Max, Mark, and Koen for this presentation, and I wish you a nice rest of the day.